Hi, this is Ali and you're watching 6th video in series How Internet is Secured. In this video, we shall go over OAuth2 authorization grants and flows. We'll start by introducing authorization grants and flows, then deep dive into authorization code grant, which is by far the most popular. We'll touch implicit grants and why they are frowned upon, then review resource owner password, client credentials, and refresh token grants. The goal of any authorization workflow is to obtain an access token. We shall cover access tokens in detail later on, but for now, just know that they are the key to unlock secure resources. A key you obtain once authorization server feels you are eligible or authorized to have it after doing its due diligence. That's all for access tokens for now. Let's focus on how to get those. Then later we shall figure out how to use them. An authorization grant is defined as a credential representing resource owner's authorization to protected resources to a client. The client uses this credential to obtain an access token. An authorization flow refers to the entire protocol to obtain an access token. Authorization grant is the credential used during that flow to obtain the access token. Another close relative is refresh token, which for now is a special token used to request new access tokens after previous one expires, without requiring resource owner to log in again. Access tokens by default are short-lived. An interesting thing to note and remember is that most authorization workflows don't hand you over the access token after successful authorization. It's a two-step process. If your authorization request is successfully processed, you are given an authorization grant, which the client uses to request the access token. Many workflows require authentication of both resource owner, that is the user such as yourself, as well as the client app or website. There are four grant types in OAuth as per RFC 6749: authorization code, implicit, resource owner password credentials, and client credentials. Let's take a look at each. Let's start with authorization code grant. This grant type is the most popular and is used to obtain both access tokens and refresh tokens. It is a redirection based workflow, and client needs to be able to interact with both browser app and authorization server. It is interactive in nature, so requires a human user to perform consent and login. The flow goes as follows. The client initiates the flow by directing user agent, that is the browser and app, to the authorization URL called endpoint. The request includes client ID, requested scopes, local state to restore later, and a redirection URL where authorization server will redirect browser or app once access is granted or denied. Authorization server authenticates you, the resource owner, using the username, password, or any other means, presents the consent screen where resource owner, such as you, grant permissions to client to access resources on your behalf. Upon successful authorization evaluation, the auth server redirects user agent back to client at its given redirect URL, provided in step 1 or during client registration with authentication server. Parameters include an authorization code and the local state provided by the client earlier. Now the client needs to authenticate itself with the authorization server. Previously, you, the resource owner, authenticated. Using the authorization code, the client issues request for access token to designated token endpoint on authorization server and includes the authorization code received earlier, along with the client ID and secret key. This is sort of a username and password for client itself for authentication. It also includes the redirect URL used earlier to receive response. The authorization server authenticates the client, validates the authorization code, and ensures the redirect URL matches the one used earlier to send authorization code. If all is well, access token and optionally a refresh token are sent as response. A major issue with this grant type is the use of client secret, which must be securely stored. So this is not an ideal workflow for browser-based sites or single-page apps without a backend. So you would see recommendation to use implicit flow instead. But remember what I just called issue is in fact a very robust security mechanism, and the alternate is horribly insecure, as we shall see soon. There are workarounds using PKCE which you can utilize to use authorization code grant in your browser-based single-page apps though. PKCE, or Proof Key for Code Exchange, is an extension to the standard authorization code flow to avoid certain attacks like CSRF and authorization code injection. It's not a replacement for client secret and is recommended on top of it. I won't go in full detail for PKCE, but would say it relies on client creating a secret key before each authorization request, and then using the same secret while requesting access token later on during the exchanging authorization code step. The auth server would deny request for access tokens if secret key is not the same. Let's talk about implicit grant now. Historically a very popular grant type loved by most as much easier to implement than complicated authorization code grant, but contains a security flaw so basic I would start its description by warning, do not use. It's not too different from authorization code flow and much simpler. I won't even repeat the steps here. The only difference is that upon successful authentication by user, the authorization server responds at redirect URL with not the authorization code, but with access token in the URL. No refresh token is issued in this grant. No need for PKCE or client secret or server-side code. So what's the issue with implicit grant? The biggest issue is that the access token being sent in the URL. Any JavaScript code hidden somewhere deep in the bowels of node modules could steal and post access token to its master by keeping an eye on URL for windows.location to contain the word access token. That is it for implicit grant. Let's discuss resource owner password credentials grant. This grant type relies on client collecting username and password of the resource owner, that is you, and then sending it to the authorization server to get access token. The benefit is that users don't suddenly see a change in context when logging in. The client can use its own themed forms to collect user information, that is the username and password, and then get it rubber stamped from authorization server. The only security feature provided is that client needs to authenticate with the authorization server, but the entire exercise is pointless when client has your credentials. The flow goes like this. The resource owner provides the client with its username and password. The client requests an access token from the authorization server's token endpoint by including the credentials received from the resource owner, such as yourself. When making the request, the client authenticates with the authorization server. The authorization server authenticates the client, validates the resource owner credentials, and if valid, issues an access token. You must be wondering, isn't this the original sin that started the entire OAuth2? Once an evil client has your username and password, the client can bypass the protocol and attempt to sign in as you, the resource owner, and access any service you have access to. That is why this is another frowned upon grant type, recommended to not be used, and is in process of being deprecated. For client credentials grant, the client requests an access token using only its credentials. Where the resources being requested access to are under its own control, or those of other resource owner that have previously arranged with authorization server. The client authenticates with the authorization server and requests an access token from the token endpoint. The authorization server authenticates the client and if valid, issues an access token. There is no logging in or something, it's a simple process. This mode is mostly used for client-to-client authorization or machine-to-machine authorization, where one client is trying to access resources held by another client or web service. We are using the term client since we have been using this OAuth terminology, but in general terms, this is usually server-to-server communication, often referred to as daemons or service accounts. The authorization is generally performed using access control lists, where the authorization server confirms the client is in a list of registered client IDs, or you can say pre-arranged setup. Refresh token grant is not a standard grant mentioned in OAuth2 grant protocol, but it is kind of a grant, and that is why we are talking about it. You will hear about it often, so good to know about this. Without going into full details in this video, refresh tokens are credentials used to obtain access tokens. They are issued to clients by authorization server upon successful completion of authorization code grant and others. The purpose is to give clients a way to obtain new access tokens when the issued ones expire or become invalid, or to obtain additional access tokens with identical or narrower scope. And here is an important bit, without the need for user to be involved. Issuing refresh tokens is complete discretion of authorization server. Refresh tokens are never used to access resources. Their intended audience is authorization server only. The flow goes as below. Client obtains access and refresh tokens using grant flow described earlier. When the access token becomes expired or invalid, then the client requests new access tokens by authenticating with the authorization server and presenting the refresh token. Authentication requirements are based on client type and
Upon
authorization server
successful
policies.
authentication of client and verification of refresh token, authorization server issues a new access token and optionally a new refresh token.
Refresh tokens are used when you remain signed in to, say, Facebook, Google, or LinkedIn on your machine. Your browser has limited ways to safely store access tokens, so usually short-lived access tokens are issued. Refresh tokens allow browser to re-authenticate and obtain access tokens, allowing you to stay logged in long after you signed in. If your access token is compromised, the attacker would have a hard time authenticating with the authorization server while genuine client can obtain a new access token. That's it for authorization code grants. In the next video, we shall look at various types of tokens used in context of OAuth2. Thank you so much for watching this video. If you like the content, please like and subscribe to be notified of the exciting new content coming up. Thank you and goodbye.